Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. It's me, Richard, here once again. Now, today we are looking at this question. It says, consider the arrangement below. This is the arrangement. It says the coefficient of kinetic friction between the 6 kg and the surface is 0.25. And the question says, calculate the acceleration of the 6 kg. Okay, when you look at this arrangement, where do we start from? Okay, the best approach is to have the free body diagram. Let's start with the 6 kg. Okay, for the 6 kg, these are the forces which are paramount here. We have a force due to the string, which is T, and that one is counteracted by Fk. So those are the two forces we are having there. We are going to ignore the vertical forces. And after having that, what do we do? Next step is to apply Newton's second law of equations. F net is equal to ma. Okay, and then when you put F net in terms of forces, then we are going to have, our assumption is that 6 kg is moving to the right. So we are going to say T cos 0 degrees plus Fk cos 180 degrees. Okay, when you simplify this, what you get F net equals to T minus Fk. Now if you substitute for F net, you are going to say Ma is equal to T minus Fk. Okay, what's the mass? The mass we are considering is 6 kg. So it's going to be 6a because we don't know acceleration. Okay, T, do you have T anywhere? It's like we don't know it, so we are going to have it like that. Then you come to our Fk. You have to remember that Fk is equal to mu k Fn. And so when you expand that one, it's going to be mu k mg. So it's going to be 6a equals to T minus mu, which is 0.25, times m, which is 6, times 9.8. So this is what we get. So the best, we are going to have 6a is equal to T minus, let's look at that. So that is what we have. So the best, what we can do here is that we can make T the subject. So when you make T the subject, you're going to have T equals to 6a plus 14.7. Okay, and that's what we have for the 6 kg mass, and we can call this equation 1. Next step is to go for our 3 kg. Okay, what do we start with? The free body diagram. 3 kg is hanging. So what are the forces which we know? We know the force due to the string, which is tension, and we know the gravitational force acting downwards. And remember, the direction we took is, it was to the right, so this is going to be downwards. You have to take the same direction. So what do we start with? You start by applying Newton's second law, which is F net equals to ma. And the m is 3, and the a, we don't know it, so it's going to be like that. That's going to be our F net. Next is to have F net in terms of the forces, which is going to be Fg cos 0 degrees, because Fg is in the direction of displacement. Okay, plus T cos 180 degrees, because it is opposite to the direction of displacement. When you simplify this, you get F net giving you Fg minus T. Now we can substitute for F net, which is going to be 3a, and Fg is mg minus T, which is going to be 3a equals to m is 3 times g, which is 9.8 minus T. When you rearrange this, then you are going to, let's make it the subject in this case. Our T is going to be equal to, let's get something here. So we get this as 29.4 minus 3a. And that one becomes our equation 2. Okay. So what do we do? Next step is to equate the two t's, because it's the same t. So next step is going to be 6a plus 14.7 is equal to 29.4 minus 3a. Okay, what do we do here? What we do, we correct like terms. So we are going to have 6a plus 3a is equal to 29.4 minus 14.7. What we get out of here is going to be 9a is equal to that. Let us see what we have. So we get 9a equals to 14.7. So from here you can proceed and get our a, which is going to be 14.7 divided by 9. What you get out of that is going to be our acceleration. So that's what we get as our acceleration. Yeah, then comes this question. It says, calculate the tension in the string. This is a follow-up on what we have been doing. Before we have to calculate this one, we have to remember that we got our acceleration as 1.63 meters per second, because we are going to make use of that. Then what else do? We get one of the equations, either from the 6 kg or the 3 kg. If we use the 6 kg, we found that tension was equal to 6a plus 14.7. So what do we do under this circumstance? You just substitute for a. So we are going to get T is equal to 6 times 1.63 plus 14.7. And what do we get? What we get is going to be So that is that. So we end up getting our tension as 24.48 newtons. With that, we'd like to thank you very much. The channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard, once again. We'll see you next time. Don't forget to subscribe. Bye-bye.